everybody. Welcome to NTWC Plus. It's a new year. Well, it's a new year for most of us. I wasn't here last week. Bill was. Hal was. But it's good to see you. Thank you for joining us on the 2026 NTWC Plus podcast and everything else we do here. We're glad to have you. This program today is brought to you by USAA. They do a lot of things for us, and we appreciate them. The South Padre Island Convention and Visitors Bureau, Live View, and the Texas Weather Network. Welcome to the Texas Weather Network to the fun that we're having. These shows every week are hosted by, along with me, we've got Bill Reed from the National Hurricane Center. Good morning, Bill. It looks like you're joining us from Tahiti or something today.
That's a nice picture. I'm actually in my office, and if I'd have to blur it if I use that because I'm in the midst of trying to change things around in here. It's a mess. But lovely weather we're having. It's so different from the last 10 years where we went dry in May and stayed hot and dry in June. We had 10 inches of rain in May, a little over, and got an inch this morning, so June's off to a good start.
Well, it's been the same way down here in deep South Texas. We've had more rain in the month of May than we've had the last 8 months leading up to it. So no complaints here. So Dr. Hal Needham's not with us today. He'll be back next week, I think. He was here last week. We appreciate Dr. Hal for all he does, and our guest today, who, Bill, I'll let you introduce him because you guys go back to, I don't know, 10, 15, 20, 30 years. I'm not sure how far back, so I'll let you get into that. So take it away, Bill.
Yeah. I tell people Jamie was a homeless guy hanging around the steps of the Hurricane Center and felt sorry for him and brought him in. I didn't feel too sorry for him. I made him take on storm surge, which is a beast, as he could well describe, and he did such an outstanding job of it. He is now the deputy director of the National Hurricane Center, and having been there and when Ed was my deputy, that is a time-consuming and important job in a place of that complexity. So welcome, Jamie.
Yeah, thank you so much for having me back.
Yeah. We usually bring one of you guys from the Hurricane Center in early in the season to kind of talk about what's new and different for those that haven't read what's new and different in your world. So I understand from some of the talks over the last year that the experiment with Google DeepMind and AI was so well received that you're probably heading towards advancements in more directions with that.
Yeah, last year was the first. We've been talking about AI in popular circles, public circles for a couple of years. Last year was really the first year of like good testing. And that testing was extremely positive for track, and we anticipate building upon that progress this year and hopefully building out better guidance in the other categories too, namely intensity and structure. Google DeepMind is not the only game in town. That's the one that's talked about most often, but not the only game in town. And fun fact, Bill, our mutual friend, Mark DeMaria, did a talk recently this week, and we can trace AI at the Hurricane Center back several decades. So we were doing AI before AI was cool. Obviously, the depth and degree of the machine learning is much, much higher. So I don't know that AI is new to our forecasters conceptually. It's just the ability to do more heavy lifting it's much, much, much better now than it used to be.
Yeah, that's true. I mean, everybody. I do the same thing. I say I think it evolved from the computer statistical techniques as somewhat of an AI aspect. I can see where Mark would come from that, and then it became machine learning, which is really just another name for AI in an earlier version of it. How do you guys view the ability to forecast genesis? Is it improving to where maybe we get a little bit longer lead time on those skill-wise?
Yeah, and the tools there are advancing, pretty quickly too. In Genesis, we always talk about forecasters have access to tools and information that may not be necessarily tossed around in the public medium so much. And Genesis is one of those areas. They really have some neat and sophisticated tools to help them with the Genesis aspect, and the lead times are getting better and better. What used to be, if we could predict things, when you and I were younger, 3 or 4 days, Genesis was revolutionary. Now you're really pushing, out into 7 to 10 days. You're starting to be able to get increasingly reliable predictions. Officially, the Hurricane Center only goes out 7 days with the outlook. Obviously, that's going to be an area of possible improvement to extend the lead times formally. Officially, if we can continue to see this reliable progress with the guidance and the tools that we use.
Yeah, that's what you mentioned. Structure. I mean, that was something. It was just. It was strictly analog hurricane specialist experiential knowledge when I was there. What are we doing to improve the structure forecasts?
Well, the numerical models are getting better, especially the high resolution models. And since they form some of the training components, training data sets for AI models, and we'll come back to that because it's an important nuance. The AI sort of benefits from that. We also have better observational systems, better observational platforms that are sort of helping build these two-dimensional wind analyses to then also train these AI systems. But a lot of people view AI versus NWP like a competition, or like one has superseded the other. What they fail to understand is that AI is only as good as the training data set. So you have to have data to go into these things to train them, or they don't get better, or they don't have accuracy. And NWP, traditional NWP, is one of the foundational data sets that can be used to train these models. So I see them as complementary. They're working sort of hand in glove, if you will, versus one versus the other.
Interesting. Another thing that I think maybe playing a role in the intensity and the structural aspects is getting more of the Doppler radar data from the aircraft in there to study these things and have a feel for what's going on when we have, for example, a rapid intensification.
Yeah, the tail Doppler radar. So you remember when you and I, when I was a hurricane forecaster, the tail Doppler radar was there, sort of like like a novel type of thing. So now it's more routinely used. We use the NOAA aircraft, which has the tail Doppler radar, more routinely now. Which, in addition to the beautiful imagery, obviously the gee-whiz imagery, there's structure components there that the forecasters can see that are a predecessor to rapid intensification. So there's signals there that the forecasters, that sort of came to bear in Melissa last year. The forecasters were able to recognize the early signs the rapid intensification is about to happen. And then there's new observational systems like, obviously the deployment of the drones this year, which have gotten a lot of early publicity and notoriety. But all of these things are coming together in time and space to give us better and better understanding of the structure of hurricanes, but more importantly, a consistent data set, right? You really want a consistent data set to train these AI systems. And so really, AI is about the training data. That's often lost in the discussion. Everybody wants to jump to the gee-whiz, look at this, revolutionizing hurricanes, that sort of thing. But it really comes down to the training data. The training data is what enables and empowers these AI systems to take these sort of radical steps forward.
Really cool. So we got the technology improvements in mind there on the forecast side. Back to your area of former expertise on the storm surge. Anything new going on in storm surge this year from the past? Or
Cody Fritz, who now leads the storm surge unit, has picked up right where I left off in terms of pushing the boundaries and making us move forward. One of the historical reasons why expanding storm surge forecast modeling services outside of the continental United States, where we have sort of a gentle continental slope, right? Sort of, we've talked about this on the show many times. It's sort of a gentle traditional storm surge. When you get into these island environments, we have a steep continental shelf, kind of like the one that's behind you in your screenshot there. It becomes more of a wave setup type physics, meaning breaking waves over and over and over again raise the static water level. And it requires a different physics package, a different modeling setup. And that modeling setup is extremely expensive. I mean, think about it. You're having to resolve the physics of over a very small period. It's when a wave breaks, that's a very small area that you're trying to resolve the physics, plus pretty complicated math. He finally, cracked the nut there and got us a modeling system that could not only resolve those physics, but do it quickly, within an operational time constraint that we operate under. And that's allowing us to expand all our storm surge products to Hawaii this year for the first time ever. So that's a full suite, including explicit storm surge watches and warnings. And if necessary, WIA or what some people call IPAWs, or push notification to one's cell phone, if a storm surge warning were to be necessary for the Hawaiian Islands.
Wow, that's amazing. I don't even think that was on our dream sheet when I was there.
Just because the mathematics.
Caribbean, then that was when I left. We were still we still had nothing outside of the CONUS.
Yeah, and the international element, you're familiar with this. The international components, are also expanding. The U.S. has, a rather large technical lead in this particular category, and it's resulting in some of our neighboring countries to the south, in the Caribbean and Latin America, reaching out and requesting assistance to expand their storm surge forecasting and visualization capabilities. And, because of our codified role under the UN and the WMO to be like sort of we call it an RSMC. Obviously that vernacular is not going to work outside of you and me, but we have the ability to provide the assistance to these countries. You're going to see an expansion of storm surge forecast in the Caribbean in the coming years.
They'll find it very useful. Tim, I'm going to toss it to you. According to my little schedule here, we do a sponsor message, and then I'm supposed to articulate something intelligent about the tropics. And when we get back to Jamie, I want to switch over into the what's new and improved in communicating impacts.
I like that. That's important. Something we've all been talking about a lot of. We appreciate that. Fascinating show. My preference today is to be a fly on the wall and let you guys talk. But we do need to mention our sponsors. So we thank them who are part of this program week in and week out. USAA, they've been here from the very beginning of the National Tropical Weather Conference, and we sincerely appreciate USAA for all they do. The South Padre Island Convention and Visitors Bureau, that's where we do the actual National Tropical Weather Conference every year in the month of April. If you've not been there yet, you should join us one of these years. We'll be back there in April of 2027. That's hard to say. Back there live, and Bill will be there. Jamie hopefully will be there along with everybody else. It's always a great learning opportunity. Live View makes it possible for all the TV stations who are at that event to broadcast back home to their home markets. So when you see your local television meteorologist doing a live broadcast from South Padre Island, that's courtesy of Live View. So we appreciate that. And the Texas Weather Network, they are new to NTWC Plus this year, and we appreciate them joining the fold. Thanks to the Texas Weather Network for being part of what we do, and everybody else who's part of making this a possibility. All right, there's your sponsor break. Bill, tropics are amazingly, well, what you would expect for June 3rd.
Yeah, let let me jump on that. What is, for those that don't know, including me, what is the Texas Weather Network?
Well, I need to let Alex jump in on that. Alex, is your mic hot? Can you explain that to us?
Yeah, the Texas Weather Network is a group of meteorologists that have come together to kind of cover most of weather for digitally online for most of South Central Texas.
There you go.
All right. Okay.
Now you know.
I'm going to share the screen here, but in the past, we've done a real-time tropical update. This show is being recorded for later broadcast, so nothing I show here will be valid when you're watching this. Please see your official sources at the National Hurricane Center and elsewhere for what's really going on in the tropics. So,
or just call Jamie's cell phone. That's fine.
Yeah, I'll just call Jamie. I'll put that up at the end of the show.
A lot of people do.
I have a joke with that, but it's not for general consumption. Anyway, we got a tremendous amount of above normal moisture all the way from New Mexico through the Gulf of Mexico down here, and it's been providing all this generous rain for the Gulf Coast region. And but in spite of occasional model hiccups, it's not forecast to generate a tropical storm. There's a lot of, you can see most of the clouds at the higher levels are moving west to east, which is indicative of wind shear over the area where the moisture is the highest, and it's helping produce the thunderstorms, but it's also inhibiting tropical development. As you would expect in a developing El Nino and at the start of the season, the Eastern Pacific is full of convective activity, and Jamie will correct me if I'm wrong, but we still have TD1 out here forecast to become a tropical storm. Let's see what else. A little closer view of the Gulf of Mexico here, and there's some lightning activity with it, and I guess it'll. There we go. And again, you can see in the motion there, everything's down low is moving pretty much to the southeast to northwest in the Western Gulf, and east to west up here. So there'll be a lot of thunderstorms offshore moving inland during the days while this pattern continues. So just if you don't believe me about the wind shear, you can take the model's word for it. It not only exists today, it's forecast to strengthen over the next several days. And I looked at the ensembles and all, nothing really hinting at anything other than a really active eastern Gulf of Mexico. There's the central American gyre is going to kind of fire up in there, and there'll be a lot of moisture down there. Right now, it looks like the spin-ups will be on the Eastern Pacific side of the spin there. We'll watch Mr. GFS to see what it gives us in there. Well, welcome back, Jamie. And my favorite topic is how to deal with messaging of impacts. It's not one of my strong suits. I'll let Tim ask a lot of questions on that because that's his job, telling people what's going to happen to them. What's new this year in the products that you guys put out that helps with intelligence on impacts?
Yeah, well, I mean, you'll notice a very methodical march towards de-emphasizing some of the legacy approaches to communication, the impact of hurricanes to newer techniques. You know, it started with you and me, Bill, where we sort of de-emphasized the Saffir-Simpson scale, at least as a communication tool for storm surge, and began to provide explicit information about the local risk, from storm surge. Obviously that has continued with better and more heavy rainfall. You've noticed a significant uptick in the game from precip, heavy precip products from our sister office at WPC, and then not to be outdone, the Water Center is bringing online inundation mapping for the inland flood side. Now, from the Hurricane Center specifically, we spent a lot of time last year, this year, making changes to the cone graphic, the infamous cone graphic that's been with us for over 20 years. Largely stagnant during that period because it was an institutionalized product, meaning once a product becomes that sort of well-known and well-entrenched, you got to be really careful about, flippantly making changes. So we really wanted to take a hard look at the data, specifically social science data and any polling and partner feedback to figure out what was going to be the most logical steps. The first one was the easiest one, the inclusion of inland wind watches and warnings, which you saw play out in the experimental cone over the last couple of years. That experimentation was so successful. I mean, the feedback that we got was over 90% of the respondents liked it. I mean, you can't get 90% of people to agree on anything these days. So we took that as really hardcore data to move forward. So that then became the operational cone. So the old version that you remember experimental the last couple of years is now the operational cone, and those changes are now permanent or codified. And then that opened up a new lane for experimentation, or a new experimental cone. And then this case, so starting this year, the first ever changes that I can recall to how the cone is actually created, meaning the shape and size of the cone has largely been stagnant since its inception. This is probably not the end of that journey. This is probably I like to call it a down payment on potential future changes to the cone that would make it a bit more dynamic in a sense of specific to that forecast situation. So the cone, for people that don't know, is based off the historical 5-year errors, so like past performance. And that has served us well, but I think predictability has improved sufficiently and technology is improving that one can start to imagine a cone that is shaped and sized based off the specific storm and the error characteristics of that particular storm situation. Now, the new experimental cone is not that, but it is a step in that direction by adding the it used to be the old cone was, total error, 5-year error. This year, we're breaking it down into the traditional cross-track era, which is like left, right, north, south, and then the forward speed. And what's fascinating about this won't surprise you because you did this for a living, is that as you get out to days 3, 4, and 5, the forward speed of the storm begins to dominate the error characteristics, meaning to convince yourself of this, you can sort of think of compounding interest, which everybody knows, like a little bit of interest compounded over time grows really rapidly. So if you're off by 2 miles per hour on the forward speed, doesn't sound like much, right? But 2 miles per hour over 5 days really adds up to a big, big error. And by taking that component into account in creating and formulating the cone, you get a slightly different shaped cone, and one that is should be more accurate because it's better accounting for the actual storm motion.
Yeah, I would always have to try to analog why I show people on the East Coast how big a problem that is. A lot of them have 3 or 4 day lead times for actions, and I said the biggest challenge is not left or right; it's when's it going to accelerate as it comes into the westerlies, and how fast you lose time if you wait for a more certain forecast.
Yeah, so time. So this is like really inside the ballpark. Everybody's, when a hurricane's coming, everybody's worried about what this model says or what that model says, or I saw the GFS or the American, the European. They're all worried about the wrong stuff. Like it's a major distraction. Time is the element that catches everybody off guard, meaning the storm inevitably changes its forward speed, either speeds up or slows down. And time is everybody I've ever talked to after a hurricane, every single emergency manager, professional, fire chief, everybody has always said that time is what snuck up on them. That, that's what they wish they had back. And so this is the part that really catches people off guard. They just fail to understand how much time it's going to take to do something. The storm speeds up, and their timelines just compress really, really rapidly on them.
Yeah, and the natural tendency to be skeptical of anything happening 3 days in advance mentally sets you up for delaying your decision making. It's very important.
So people,
constantly come up with new ways to try to get people to you're better off jumping the gun on this thing and getting the job done than waiting.
Yeah, there's often a financial incentive to wait, right? So if you don't have to go out and buy supplies, especially as expensive as things are these days, clearly people are going to skew in that direction, right? And so what happens is people shop for the information that allows them to delay a decision. And there is no shortage of information out there. You can easily find information to support any decision, even if that information is bad. In many cases, it is, but because there's often people pushing social media content or video content that's not accurate, and then people shopping around finding a model that supports their decision. This is the number one challenge that faces all of us as weather communicators right now, that if somebody doesn't want to do anything, they can go find someone that'll tell them that's the right decision.
Is there a way of expressing confidence in that forecast? I know like the local weather service office, when they put out a special weather bulletin or something, at the bottom there'll be a little forecast confidence meter that at least gives the public an idea of how good they feel about that.
Yeah, expressions of certainty or uncertainty is one of the big areas in weather communication. And so the new cone kind of tackles that. I think a lot of people, rightly or wrongly, ascribed a level of accuracy or confidence to the cone that wasn't well rooted in the understanding of the cone. And we looked at how people naturally perceive the cone, and then we built a cone that I think better matches people's perception of the confidence. So the old cone was 67%, or the center would stay inside the cone 67% of the time, or 2 out of 3 times. The new cone is 90%. And if you think about the words one would use in 90% versus 67%, there's a significant uptick in the confidence that one can ascribe to the new cone that I think is going to help people better understand and accept that type of messaging. The old cone, you would probably say potential path or that sort of thing. Whereas the new cone, you can say 90%. You can say probable or most likely path. Fair bit of confidence boost there.
Well, that definitely helps. I think that's good to see, because because people see the cone and they react to it. They're in or they're out, but with all the warnings added to it, that makes more sense. Any thought of changing, updating, eliminating the Saffir-Simpson scale? Any changes?
That comes up a lot. Saffir-Simpson scale still has a little bit of value in storms that are going up, meaning intensifying, because it's a very easy, convenient way to sort of state, hey, this storm has rapidly intensified, or is now stronger, that sort of stuff. So it still has value there. Where we get in trouble is on the way down. So when you say, so-and-so storm, Hurricane Tim has been downgraded, right? Or has that is where it starts to hurt you. Sort of similar to the cone, it's so institutionalized that we really have to take a very careful look at that. But the one thing I can say, and I think everybody on the panel here has heard me say this before, but it hasn't sort of reached mainstream public yet, is we're not looking at investing in the Saffir-Simpson scale in a sense of adding like a category. There's no efforts afoot to add a category 6. I actually heard somebody recently suggest a category 8, and I was like, wow, you really jumped the gun there. But so there's no effort. There's no effort really to invest in scales. I think scales have sort of run the course. They serve their purpose. And now there are just much better ways to communicate risk to people that are localized to them and specific to them.
Yeah, there's so many factors in there. Someone made a post the other day, which was very interesting. We're now in our longest stretch on the upper Texas coast of a landfall of a major hurricane, Alicia. And it's funny, upper coast, not you guys, upper coast.
I'm still knocking on something here.
Yeah. So the immediate feedback, I shared it because it was a good, well-written one. And the immediate feedback, what do you mean? We had Ike. Ike was 5 miles an hour below a Cat 3. It's a step function. And I don't like scales for that reason. There's always...
Bill froze up on us. It was really important.
I can help finish his train of thought that, scales conflate a whole bunch of information into a single number. And at the end of the day, people really need to know their specific risk at their location. Is it rainfall? Is it flooding? Is it storm surge? Is it wind? Yep. They need to know the specifics. And, the way I try to explain this is, the public is much savvier than people want to give them credit. They can understand risk. They can understand maps and these sorts of things. And by investing in these new communication techniques, we're basically investing in teaching and training people how to do a much better job of deducing their own personalized risk.
Yeah. One last thing before I kick it back to Tim there. I've always felt that the emphasis on sustained winds misses the point. It's as soon as the storm makes landfall, it's gusts. That's all we're measuring that reach those high values. So what are we doing to communicate the fact that we are getting a lot of high gusts, and that's what's causing the damage?
Yeah, great question. For you guys know this because you saw some of the polling we did at the conference this year, but maybe not others. I think Fujita said it best. The peak damage is done by the peak wind, no matter how long it blows. Meaning, the gust really is, especially at higher wind speeds, is really the determinant in damage. Be it home damage or power loss or trees down, that sort of stuff. And sustain doesn't always capture that part particularly well. The sustained is, going to be lower than the gust. And so there's a fair bit of effort right now looking at, how would we switch to communicating gust, or, even, could our warning paradigm evolve such that gust could be a function of the decision-making process of when and where to issue a warning.
Perfect. I want to keep this conversation going all day. This is fascinating, but we promised we get you out in 30 minutes, and we're at 35 now, so we've gone long. I have a whole list of questions here that I want to ask. But Bill, give us your last thought before we give Jamie a chance to wrap up his thoughts.
Yeah. It's always great having you here, Jamie, and anybody from the Hurricane Center. It always puts a warm spot in me to see how far advanced the Hurricane Center has come since I was there. Maybe it's in spite of my being there, who knows, but it's great to have you, and have a good season.
Yeah, thank you so much for having us back. This is always a treat to come back and see familiar faces. Any
thoughts you want to leave us with, Jamie?
Yeah, a lot of bad information out there these days, and it seems to multiply. All the individuals here are trusted, reliable sources. Find your trusted, reliable source and stick with them. Don't just randomly believe stuff you see on social media.
If it's on TikTok, it's not necessarily true. So thanks, Jamie. Appreciate it. Bill, great job again today, as always. Good to have you guys. And it's always fun to just, again, be a fly on the wall and listen to the conversation, because it's fun to hear all the insight. We want to thank our sponsors who are part of the program once again: USAA, the South Padre Island Convention and Visitors Bureau, Live View, and the Texas Weather Network. Next week, Mark Suddeth from Hurricane Track will be with us. Always a fascinating program, so we encourage you to tune in for that. Again, that's it for NTWC Plus for today. Have a great week. We'll see you next time.